All right, guys, this is Mr. Dermott with the Unit 4 test corrections video. Please follow along. Make sure you show all of your work as we're rewatching and relearning this. A couple of issues with the signs on this, so make sure you're checking to make sure you're copying them down correctly as we're solving them. I'll be doing the same because my copy is not that great. Looking at number one, this is what value of x makes this equation true. This is just asking us to solve this equation. So we're going to go ahead and do that. I'm going to start by copying the equation down in my room for work here. Negative 7x plus 4 minus 3x equals negative 2x minus 12. So to solve this, it's going to be simply combining like terms and then getting my variables on the left and then doing reverse operations. Combining like terms, this is going to leave me with negative 10x plus 4 equals negative 2x minus 12. I need to get the variable on the left since we have a variable on both sides. I'm going to cancel this negative 2x out by adding 2x to both sides. This is going to leave me with negative 8x plus 4 equals negative 12. I want to isolate this variable term right here. So I'm going to get this term off of this side, get this constant off of this side, cancel it with a negative 4. Apply that to both sides. That's going to leave me with negative 16. Negative 8x equals negative 16. And the last thing I'm going to do is I'm going to get rid of this coefficient. The operation there is multiplication, so I'm going to divide by that coefficient. These two are going to cancel. I'm going to have x equals negative 16 divided by negative 8. Negative divided by a negative is a positive. That's going to be a positive 2, and that's my solution. Number 2, we're solving for x. Now, notice that we have a cube situation. A cube is a number times a number times a number. So with this one, we're going to, again, copy it down. X cubed minus 24 equals 40. I'm going to get my variable term isolated, so I've got to get this negative 24 off this side. I'm going to add 24, add 24. And then I've got x to the third power equals, x cubed equals 64. So to get rid of this exponent, I'm going to do the root of it. I'm going to do the cubed root of that side. I'm going to do the cubed root of the other side. So when I get the cubed root of x to the third power, I get x, because x times x times x is x cubed. What number can I multiply by itself 3 times to get 64? That number is 4. 4 times 4 times 4 is 64. 4 times 4 is 16. 16 times 4 is 64. Moving on to number 4. We need to solve for x. We remember that the interior angles of a triangle add up to 180. So I'm going to write an equation with each of these terms that adds up to 180. So I've got x plus 31 plus 70 degrees plus 90 degrees equals 180 degrees. My first step, only a couple steps here. I'm going to combine my like terms. 70 and 90 is 160 plus 31 is 191. So x plus 191 equals 180. Now I need to get my variable on its own, so I'm going to subtract 191 from both sides. I'm going to go into the negative here. These are going to cancel. I'm going to have x equals negative 11, and that's my solution. Continuing to move on here, we're going to, for number 5, not a great copy on this one, so I'm going to copy this down carefully. I've got 2 times 3r plus 4 minus 3 times r plus 1. Did not write that very neatly. R plus 1 equals 11. So my first step is going to be to distribute I'm going to distribute both of these. Remember to include the negative sign when you distribute. So let's see what we get here. We get 2 times 3r is going to be 6r. 2 times 4 is positive 8. Negative 3 times r is negative 3r. Negative 3 times 1 is negative 3. And then all of that is equal to 11. My next step is going to be combining like terms. I've got a couple sets of like terms that I can combine here. So I've got 6r and 3r. I'm going to combine those. It's going to leave me with 3r. I've got 8 and negative 3. I'm going to add 8, subtract 3 from it, and I'm going to get positive 5 equals 11. And then the last thing I'm going to do is, second to last thing, I need to get my variable term on its own, so I'm going to deal with this. This is going to cancel, leave me with 3r equals 11 minus 5 is 11 minus 5 is 6. Took me a second. Need to get rid of this coefficient. There's a multiplication there, so I'm going to divide. These cancel. I'm going to be left with r equals 2. And there's my answer right over there. All right. Continuing to work here. What value of x satisfies the equation below? So I'm going to again start by copying nicely, neatly, and accurately. 7 minus 2 times negative 2x plus 7 equals negative 4 plus 1/2 times 8x minus 6. My first step is going to be distributing. So I'm going to distribute this negative 2 to each of those terms in that expression. I'm going to distribute this 1/2 to each of the terms in that expression. Negative 2 times negative 2x is going to be positive 4x. Negative 2 times positive 7 is negative 14. 1/2 times 8x is going to be 8x over 2, and that's the same as 4x. So I'm going to go ahead and positive 4x. 1/2 times negative 6, 1/2 of negative 6 is negative 3. Now I have a couple of terms that I've not touched. That 7 is going to come right down there. That negative 4 is going to come right down there because I haven't touched it. My next step is to combine like terms. There are my like terms on that side. There are my like terms on the right side of the equation. 7 minus 14 is going to be negative 7. So I've got 4x minus 7. Negative 4 minus 3, going 3 more into the negative, so that's going to be negative 7. Okay. So I see something right here. I'm equal on both sides. This is going to be one of the special cases we talked about. Let's play this through. I need to get my variables on the left, so I'm going to subtract 4x, and what you're going to notice here is at this point, all of our variables have completely canceled each other out, and we're left with negative 7 equals negative 7. When you're left with a number times a number and no variables, remember, if the numbers are the same, then it's going to be infinite solutions. If the numbers are different, it's going to be no solution. In this case, we're infinitely many solutions. Number 7, which equation has exactly one solution? So I want to look back at this one really quick. You notice how we got down to a step where we had 4x on this side and 4x on this side. When you get to a situation where you've simplified the variable terms on both sides, combined like terms, and you're left with one variable term on each side, if those variable terms are the same, then you're going to be left with either infinite many solutions or no solutions. When the variable terms are not the same, you're going to end up left with variables to deal with, and you're going to be able to find a solution to the equation. So really what we're looking for on this one is instances where the variable terms, where you have an unequal value of variable terms on both sides. So just for kicks, let's start out with D on the bottom. See, and all we're going to do is we're just going to combine our variable terms, okay? So for D, we've got 3x plus 6 plus 2x plus 5 equals 5 times x plus 2 plus 1. So all I'm going to do is I'm just going to combine my variable terms, right? So I've got 3x, I've got 2x. When I combine those guys, I'm left with 5x plus 6 plus 5, but I'm really interested in that right there, my x variable. When I distribute this 5 to both of these terms, I'm left with 5x plus 10 plus 1. So at this point, I'm done here because I can already see that I've got 5x on this side and 5x on that side. These are going to cancel out, and I'm either going to have one solution or infinitely many solutions. I'm either going to have no solutions or infinitely many solutions. So I know that this is not an answer because the question is asking us to find the equation that has just one solution. It's not even asking us to solve it. Let's try A and see what we get for A. So I'm going to copy down A. 7 times x minus 2 equals 7x minus 2x plus 4. So let's just play this out. Over here, I'm going to distribute. Then on this side over here, I'm just going to combine my like terms. When I distribute that 7, I'm going to have 7x minus 14. When I combine these like terms right here, I'm going to have 5x plus 4. So I want to note here that on this side, I've simplified. This is the only variable term on this side. This is the only variable term on this side, and they're different, right? So I know that whenever I work to get my variables on the left, because I'm going to subtract 5x from both sides, on this one, you can see that I'm left with 2x minus 14 equals 4. So at this point, I'm going to have variables left over. When I play this out and solve the rest of this, I'm going to be left with an x, right? I'm going to be able to solve for one x. So this does have one solution. So the answer is A. Moving on to number 8. When 8 is added to a number that is produced by doubling the number x, the result is equal to 8 times the number that is 5 less than x. What is the value of x? Okay, so we really have to kind of parse this out. When 8 is added to the number, so it's going to be 8 plus a number, but let's see what that number is. This is the number that is produced by doubling x. So it's 8 plus 2x. That's the number that is produced by doubling x. The result is equal to 8 times the number that is 5 less than x. So how could we show a number that is 5 less than x? This is going to be a parenthetical, right? So we're going to start with x. This number is 5 less than x, so I'm going to subtract 5 from it. And then there is our equation, and we've got to solve for x. And so this is a pretty easy equation for us to solve. We're going to distribute. We're going to distribute right here. I'm going to have 8x minus 40. And then over on this side, I've got 8 plus 2x. I've got variables on both sides, so I need to get my variable on the left. I'm going to get this 8x over here, so minus 8x minus 8x. And I have negative 6x. So I've got 8 minus 6x equals, these canceled, negative 40. Okay. I want to isolate my variable term, so I've got to get rid of this 8. I'm going to subtract 8 from both sides. Starting with negative 40, I'm going 8 more into the negative, so I'm going to have negative 48. So I've got negative 6x equals negative 48. I need to get rid of this coefficient of -6, so I'm going to divide by -6. It's the inverse operation of multiplication. These are going to cancel. I'm going to be left with x equals 48 divided by 6. Negative 48 divided by 6 is 8. And a negative divided by a negative is a positive, so it's going to be a positive 8. And there's my answer over there. All right, last question on this side. Solve for x. Don't have a lot of room, but I think we can get it done. 6 times -4x minus 3 equals -6 times 3x minus 3. Going to have to distribute. I'm going to distribute on both sides. Don't forget we're distributing a -6 on this side. So 6 times -4x is -24x minus 18 equals -6 times 3x is -18x. -6 times -3 is positive 18. I'm going to get my variable on the left, so I'm going to add 18x. I'm going to add 18x. That's going to leave me with -6x minus 18 equals 18. I'm going to isolate this variable term. I need to get rid of this -18. I'm sorry, I need to get rid of this positive 18. Ooh, that is a... Yes, it's positive 18. So I'm going to get rid of this positive 18 by -18. Oh, what am I doing? I apologize. I need to isolate this term. So I'm going to say positive 18, positive 18. That was unnecessarily complicated. I apologize, guys. This is the term I'm trying to move off. A little distracted by the announcement. So I'm left with -6x equals 36.
Good morning, staff. Happy Hump Day. Just a reminder, this afternoon we will be in the Media Center for PD if you are academics. Also,
my last step is to eliminate this -6 coefficient. So over here, I'll just copy this down. -6x equals 36 divided by -6 divided by -6. I'm going to be left with x equals 36 divided by 6 is 6. It's a positive divided by a negative, so that's going to be -6.